Most people use gears every single day without ever thinking about what they actually do. Your car, your bike, your washing machine, even power tools, they all rely on one simple idea. Gears change how force and speed are used. Let's look inside a gearbox and see how this really works. At its core, a gearbox is a system of rotating wheels with teeth called gears. When one gear turns another, it doesn't just pass motion forward, it changes it. If a small gear turns a larger one, the large gear spins more slowly, but with more force. If a large gear turns a smaller one, the small gear spins faster, but with less force. Nothing magical is happening. Energy is simply being redistributed. This is why gears are so important. Electric motors and engines like to spin fast, but wheels, drums, and tools often need more strength than speed. The gearbox acts like a translator, turning fast rotation into useful power. Now let's look at what happens when you change gears. Inside a gearbox, multiple gear pairs are available. Each pair has a different size ratio. When you select a gear, you're choosing how that power is shared between speed and force. Low gears use larger ratios. They provide high force but low speed. High gears use smaller ratios. They allow higher speed with less force. That's why cars use low gears to start moving and higher gears to cruise smoothly. But gears don't just change speed, they also reduce strain. Without a gearbox, an engine would struggle to move heavy loads. It would overheat, waste energy, and wear out quickly. By using gears, the engine stays in its efficient range, while the gearbox handles the hard work. Now let's talk about wear. Inside a gearbox, the most stress happens at the gear teeth. Every time gears mesh, their teeth press against each other under enormous force. Over time, this causes friction and heat. That's why gearboxes use lubrication. Oil creates a thin protective layer that reduces contact between metal surfaces, removes heat, and prevents damage. Without proper lubrication, a gearbox can fail surprisingly fast. Bearings also play a critical role. They support the rotating shafts, keep everything aligned, and reduce friction. If bearings wear out, gears become misaligned, which accelerates damage even further. Most gearbox failures start small and grow silently over time. So why do gearboxes sometimes feel rough, loud, or slow? Usually it's because oil is degraded, bearings are worn, or gear teeth are damaged. The system still works, but efficiency drops. More energy turns into heat and noise instead of useful motion. Despite all this complexity, the idea behind a gearbox is beautifully simple. Gears don't create energy. They don't destroy it. They simply decide where that energy goes, more speed or more force. And that single decision is what makes modern machines possible. The next time you shift gears, hear a quiet hum or feel smooth acceleration, you'll know what's happening inside.